Hello, students. Welcome back. So, in this session, we are going to cover scatterplot. It's one of the most important visual tool and very commonly used tool in statistics. We will learn what a scatterplot is, why is it so useful, and how to read, how to interpret your scatterplot with the real life examples. And also, we will try to look at some of the common pitfalls to avoid when you use scatterplot. So scalar plot is a type of graph. Okay, it shows the relationship between two variables. Generally, those variables they are quantitative or numerical in nature, meaning they are numbers. Okay, that's what they are. Now you have x-axis and you have y-axis. So when you do your scatter plot, you have x-axis. You put one variable along x-axis, and the other variable would be along your y-axis right here. Now your x-axis, another name for that is independent variable. That's another name for x-axis. Your y-axis is generally referred to as dependent variable or response variable. Now each dot would be your data point. So let's take a look at this example, 2 comma 5. How do you plot that? Well, this is 2 comma 5, so you go 2 unit in this direction. Okay, this is my 2 unit in this direction, then go 5 unit on along y-axis. Okay, so this point would be my 2 comma 5. What about 4 comma 8? This one right here, same thing. You go 4 unit in this direction, okay, and then you go 8 unit in this direction. This would be my 4 comma 8. Okay, now let's try to see some of the important applications of your scatter plot. Let's say you have this data right here. Okay, this is the data that's given to you, and this data represents the hours a student studied. Okay, for the exam and the scores they obtained. So just by looking at this data, it's hard to tell that whether is there any relationship between hours studied and scores. I mean, it's hard to tell just by looking at these numbers. But if I do a scatter plot right here, okay, if I perform a scatter plot of that, if I draw this scatter plot, then you can see that as the number of hours a student studies, you can see that as he studies, as the number of hours he studies goes up, his score also goes up right there. You can see a clear trend right there. You see that as the hours is basically this is the line is kind of like following this line right here. You can see that the hours as he studied, his score also goes up. Now let's take a look at another example. In this case, it's a negative a linear relationship. So this is my data right here, and this data actually is a relation between two variables, which is hours gaming. Let's say a student plays video games, and this represents how many hours he played video game, and this is his exam score, how much he scored in the exam. And by looking at this number, sometimes it can be hard to know whether there is any negative or positive relationship over here. But if you plot this, okay, you plot this thing, and now when you plot it, now you can tell that as the number of hours, okay, as the number of hours increases, his score decreases right here. Okay, this is my y-axis right here. Okay, so as he plays more video games, the number of hours he spends more on the video game, his score is going down. So by looking at your scatter plot, you can get a better visual representation, better visual on your data. Now let's look at this example. This is a third example. In this case, you can see that there's clearly no relationship. Just by looking at this, you can tell there is no relationship. And what that data is, by the way, well, this data actually is telling you there is a push-ups right here. So there is a column for push-ups and there is a column for scores. So this actually represents how many push-ups a student can do, and this represents how much score, what was his score in the test. And so this is the data that's collected, and when you plot it, right? By plotting it, you can tell that there is essentially no relation. Okay, there's no relation between your push-ups and your exam score. So as your push-ups is going up, sometimes your exam score goes up, sometimes it goes down. It's basically all over the place. So there is no clear linear relationship between number of push-ups a student can perform and the scores. Okay, so why exactly scatter plots are useful? Okay, well, number one, they identify relationship. We just saw that a minute ago. So they detect your correlation between two variables. Okay, what it means is that they tell you like how strong the relationship is. Is it like, and also the direction. So, for example, positive correlation. Positive correlation means that both variable will increase simultaneously. So, look at this example right here. As the number of hours was going up, as the number of hours a student studies increases, his score also increases. So in this case, this would be my positive correlation. This is an example of my positive correlation right here. A negative correlation, on the other hand, is opposite. Okay, in this case, your hours, as the number of hours a student plays video game, his score, you can see that his score actually decreases right here. Okay, so in this case, it's a negative correlation. Then there is a no correlation. So over here, you can identify just by looking at the graph right here. you were able to identify that there is no correlation between the number of push-ups a student can do and like his exam score. So this is one of the application of your scatter plots. You can find if there's any positive, negative, or no correlation between two variables. So then another one would be to identify strength of relationship. So look at this one. This one actually is showing that as the number of hours this student studied, right? Look at his score. It's almost following a linear line right there. It's almost following a line. This, on the other hand, is not following a line. It's just, you can tell that as the number of hours a student studies, right? Your exam score is going up. It is going up, but it is not going straight up. Okay. This one, on the other hand, you can tell it is going straight up. So this one has more strong correlation. So this one actually has more strong correlation. This one, on the other hand, has weaker correlation. So strong correlation, generally they are points. They will be very close to a straight line. And you can see that these points right here, these, all these points, right? They are very close to a straight line. These ones, on the other hand, they are not very close to a straight line. They are going in that direction, but they are not very close to a straight line. So another application of your scatter plots is to spot outliers. So these are the points that do not fit your pattern. These are the points that are kind of like unusual, or think of them as an unusual observation, that they do not belong there. Or maybe they belong there, but maybe there was a mistake. Maybe there was a measurement error, or maybe there's a reason they should be there. So in this example, you can see, look at these points. Okay, these points are going like that, but all of a sudden you have this point right here. Okay, so this point right there is your outlier right here. So by looking at these points, you can identify that are there any outliers or not. So scatter plots are useful to identify these outlier points. So anything that is not following the trend, if any point, any group of point that's not following the trend, that those points generally they are considered to be as an outlier. So another example would be you visualize to visualize clusters. So let's say this is my X data, okay? This is my corresponding Y data. So for if my X is 2.2, okay, its Y value would be 3.7, okay? This X is 1.9, another value, this Y value would be 2.9. So basically I'm just plotting this like that. I'm not writing this data in a tabular format. I'm writing this on a horizontal axis. So now when you look at this data, let's say your X could represent distance from the home. Let's say how far an employee is living from his office, okay, like how far his home is from his office. And this the Y could be, let's say, the amount of money they spend on the food. And we're trying to determine that, hey, is there any relation between them? So just by looking at this data right here, okay, just when you look at this data, okay, it can be hard to tell if there's any relationship between them. But what if we plot them? Okay, let's plot them. And when we plot them, now you can see that there are some clusters over here. You see these groups of people are together, these groups of people are together. So that tells me that there is some pattern over here. And by looking at this scatter plot, you can identify, you can actually isolate your clusters. You can spot your clusters. They are a lot easier when you actually have scatter plot. Now, so let's look at some of the common mistakes people make when they work with a scatter plot. Let's say you have data right here, okay? Name, department, years of experience, and salary. So scatter plot, they only make sense for the columns that have numerical data. This is important. They only make sense for the data that is numerical in nature. If it's a categorical in nature, then it does not make sense. For example, take a look at this one right here. Okay, this one is department. Now, although all the data in there is number, right? 1 2 2 3 1, but each one of these numbers, they actually represents a department. So 1 represents HR, 2 represents sales, 3 represents finance. So in this particular instance, you do not want to use your scatter plot, because scatter plot in this case, it only makes sense when you columns are both columns are pure numerical in nature. This one department is not technically numerical, it's more like categorical. So one, I could have written down HR, okay, because one is HR, and your two is sales. So this is sales department, okay, this is sales. All right, this is my finance, right? This is my finance right here. So basically, these are all categorical in nature. So you do not want to plot, you do not want to have a scatter plot between department and the other columns, but you can have scatter plot between these two. So this is good. All right, so this is good, but you do not want to plot. This is not, do not use for scatter plot, okay? So do not use for scatter plot. All right. Okay. Now, another one. Sometimes you can misinterpret correlation as a causation. Okay, sometimes it can be a little bit misleading. Let's look at an example. So just to give you an idea, just because two things move together, okay, just because two things move together, that does not necessarily mean that one causes the other. A good example is this. Let's say that you study, that you do some kind of study, and you discover that as the ice cream sales goes up, your electricity demand also increases. Okay, now, you may actually think of this way that, hey, maybe the increased ice cream consumption leads to higher electricity demand. Okay, maybe you think this way. But the other reason could be that there could be a lurking variable. Okay, maybe there is a lurking variable, and the lurking variable is a seasonal temperature. That warm weather, okay, warm weather causes both. So you have ice cream. Let's say this is your I variable, this is ice cream, and this is your electricity demand. Let's say this is my E. So this is my I and this is my E. Now, we may think that because your I goes up, your electricity is going up, that means there is a direct relationship between ice cream and electricity. But it is not. Basically, what's happening is that you have a weather right there, a warm weather. Okay, this warm weather is affecting your sale of ice cream. So, as the temperature increases, your people buy more ice cream. This is the direct relationship. And as the weather increases, your electricity, or as the heat increases, okay, as the temperature increases, people they consume more electricity, and that's why your electricity demand goes up. So it is not that the ice cream is causing the demand in electricity. It is just that the increase in weather is causing the increase in sales of the ice cream, and also the demand increase in the demand for electricity. Then some of the applications of this scatter plot is in education. So we saw one example, hours studied versus marks scored. Another example would be calorie intake versus weight gain. So let's say you have two columns. You can actually have calorie intake over here, and you can see weight gain. Okay, you can just verify that, hey, is there any relationship between calories consumed and the weight a person gained? Okay, another would be business. So in business, for example, advertising spend and sales revenue. So you can have one column with how much money they spend in the advertisement. The other column could be what is the sales revenue. You can see if there's any trend between them. Another one would be in economics. For example, inflation versus unemployment. Does inflation, when the inflation goes up, does it, or when the inflation goes down, does it actually lead to any change in the unemployment rate? Okay, data science also. So sometime in data science, you want to find feature relationship before you do modeling. So a lot of time, let's say you have two variables, you want to check if these two variables are related or not. So if they are related, you take appropriate measures based on that.